This video is going to look at how to determine the max and min from a quadratic function. As you remember, a quadratic function, when you graph it, looks like a parabola. It has a maximum if it looks like this. Excuse me one second. This would be a maximum. And this parabola here has a minimum. The point at which the parabola changes direction from, in this case, decreasing on this side to increasing on this side, where it changes is the vertex. This vertical line is called the axis of symmetry. It's the axis of symmetry because if you put a mirror along that line, the parabola would look the same on both the left and the right-hand side. When a question is asking for a maximum or a minimum value from a quadratic function, it is not asking you to find the entire vertex. Save yourself a little bit of time. Remember that they're only looking for the y-coordinate of the vertex. And you can tell whether it's a max or a min by looking at the a value. What do I mean by the a value? Well, there are three different ways that we can talk about a parabola. We can write about it in standard form. Standard form is great if you're going to use the quadratic equation. Negative b plus minus square root of b squared minus 4ac all over 2a. That's what if you're going to use this quadratic equation, you have to make sure that your quadratic function is in standard form. If you want the vertex, that is the coordinate of the vertex from your parabola, you're going to look at it in vertex form. The vertex from vertex form is there. We have a parabola. The vertex would be hk, where h is the number inside the bracket, but you got to watch the sign. If the h is negative in this bracket, h is positive here. H is positive in this bracket, it's a negative coordinate. It would be on this side. K stays the same sign. If it's positive, it stays positive. Negative, it stays negative. This is your maximum value or minimum value. Factored form is useful when you're finding the roots of the equation. That's to say where the parabola hits the axis. There and there. We're going to focus on how to change standard form to vertex form. How do you know whether your parabola has a maximum or min value? Well, you got to look at that a term. The a term. Either the a term in the standard form, a term in vertex form, or a term in factored form. It's all the same a term. If a is greater than 0, that means the parabola opens up, and we have a minimum value at the bottom. If a is less than 0, let's say if a is a negative number, the parabola opens down, and we have a maximum value. We want to change we want to change everything into vertex form if we're looking for the max or the min. That means that we have to somehow change our standard form into a vertex form. To do this, we're going to have to complete the square. Completing the square is a set of steps that we're going to follow to change this form into our vertex form. The steps don't make tons of steps as you go along, but eventually it just kind of clicks. So our example 1 is going to be we're going to change f of x equals x squared plus 12x plus 40 into vertex form. All right, so what are we going to do? Step 1, we're going to take our f of x equals x squared plus 12x plus 40, and we're going to put in brackets. Put in the brackets around the x squared term and the x term. Step 1 is pretty straightforward. Step 2 is to factor out any number that's in front of the x squared. In this case, there's nothing in front of the x squared, so Step 2 is kind of a wash. Don't need to do anything. There should still be an f of x here. Step 3, we're going to take that middle term. Oops, I'm referring to 12 here. We're going to take that middle term, we're going to divide by 2. We're going to take the answer and square. So 12 divided by 2 is 6. 6 squared is 36. Great. What do we do with that 36? Well, we're going to put it in the bracket. That 36 is going to be added and subtracted. Make sure these go inside bracket. So by doing this, we haven't actually changed the value of the equation. We've added and subtracted the exact same thing. We're doing this for convenience, and I'll explain why at the end, because right now it doesn't make a lot of sense. The next thing is we want that negative 36 we just put in, we want to get it outside the bracket. But to get it outside the bracket, we need to multiply it by whatever number sitting out front. In this example, the number sitting out front is a 1, so when we multiply negative 36 times 1, it remains negative 36. The next example will show one where it has to switch. Alright, step 6 is going to be taking negative 36 and 40, and we're going to put them together as 4. So step 6 is to put together the two constant terms. So let's see what we have here. What we have left in this bracket is called a perfect square. P-R-F-E-C-T. Square trinomial. Okay. A perfect square trinomial can be factored. It's going to be x plus 6 and x plus 6. And still the plus 4 stays outside. How did I know that it was going to be x plus 6, x plus 6? Well, when we put this 36 in for a reason. We put this 36 here so that it would become a perfect square trinomial. I know that, the next one. So I've factored, and I've got my last answer. I know that I want this to be in the form f of x equals, open bracket, x, that's my first term here. It's going to be a plus, that's what I have here. And I'm going to take this 36 and take the square root. 6 squared, and plus 4 remains. That's it. That's it in vertex form. Oops. Sorry. Let's just go look at it nice. There we go. My poor penmanship. This is vertex form. I can see that it's going to have a minimum value because the positive a term tells me that my parabola opens up, and I can see that that minimum value is going to be plus 4. The x coordinates of that vertex is negative 6. Remember, this positive 6 corresponds to a negative 6.